So let's start with the 1905 paper of Einstein.
The 1905 Miracle Year paper. Einstein's photoelectric effect paper tackled something profound. It proposed that light could act like packets quanta of energy. This was a huge break from classical wave ideas. In short, light can knock electrons out of metals, and that only made sense if light came in discrete chunks. It planted the seeds of quantum theory, and eventually, Einstein won a Nobel for it.
What was the architecture of the paper that he designed and he proposed actually? I think he made the calculation alone and then based on the previous observation and the results.
In that paper, Einstein proposed that light energy is delivered in discrete packets, later called photons. He built on Planck's quantum hypothesis, but extended it to explain the photoelectric effect. He proposed that the energy of these packets is proportional to their frequency. His architecture involved a direct linear equation, energy equals Planck's constant times frequency. Then, he argued that only light above a certain frequency can eject electrons from a metal, explaining why there's a threshold frequency, something classical wave theory couldn't explain. And yes, he largely worked solo on this.
But how did he propose and write all those things? First, like quanta of energy, quanta hypothesis.
Einstein took inspiration from Max Planck's earlier work. Planck had introduced the idea that energy emitted by vibrating atoms comes in discrete chunks, quanta, when studying blackbody radiation. Einstein boldly applied that quantum idea to light itself. He proposed that light isn't just a wave, it's made up of these energy packets, each with energy proportional to its frequency. In writing the paper, he combined theoretical reasoning with empirical facts. He drew on observations that the wave theory couldn't explain, like why higher frequency light, not just brighter light, was needed to free electrons. His genius was linking these experimental puzzles to a radical theoretical proposal, all on paper.
Did he use some experimental thought or it was purely mathematical calculations?
He didn't conduct any experiments himself, but he was deeply informed by existing experimental results. For instance, Philip Lenard's work on the photoelectric effect showed that the energy of ejected electrons depended on the light's frequency, not its intensity. Einstein took these experimental puzzles and provided a theoretical explanation. His paper was mathematical in argument, using equations and logic to explain what experiments had found. But he relied on others' empirical data to ground his revolutionary proposal.
Photoelectric effect so that the energy of ejected electron dependent on the light frequency, not its intensity.
Exactly. Classical wave theory had predicted that if you shine more intense light, brighter light, you should eventually give electrons enough energy to escape. But experiments showed that if the light's frequency was too low, no electrons were ejected, no matter how bright you made the light. Einstein's insight was that only light of a high enough frequency, so each photon had enough energy, could eject electrons. Thus, it's frequency, energy per photon, that dictates electron emission, not the total intensity of light.
I think the paper title was on the electrodynamics of moving bodies.
That's a great paper too, but you're thinking of a different one from the same miracle year. On the electrodynamics of moving bodies was Einstein's special relativity paper. The photoelectric effect paper was titled On a Heuristic Viewpoint Concerning the Generation and Conversion of Light. Both were revolutionary, but each tackled a different fundamental concept.
Okay, the photoelectric paper that he wrote, basically he showed that incoming light was coming from the sun, majority from sun, but when that light hit a metal surface, inside the metal what is going on and how the energy is transferred and emitted. That was the observation he made, but without any experimental thing, how can he write all those things?
Einstein didn't need to observe what was happening inside the metal directly. He used logic and known experimental outcomes. Scientists had already observed that when light of a certain frequency hits a metal, electrons are ejected. Classical physics couldn't explain why there was a frequency threshold. Einstein proposed that light's energy came in packets, quanta. When a photon hits an electron, it transfers its energy all at once. If that energy is enough to overcome the metal's binding energy, an electron escapes. Einstein explained the energy transfer in terms of individual photon electron interactions. The brilliance of theory is that it interprets observations, even those we can't directly see, by providing a consistent explanation.
What was that consistent explanation that he provided?
Einstein's key explanation was that light itself comes in discrete packets, later called photons. Each photon has an energy equal to Planck's constant times the frequency of the light. When a photon strikes an electron in the metal, it transfers all that energy in one go. If the photon's energy is greater than the work function of the metal, the minimum energy needed to free an electron, the electron is ejected. If not, no electron is emitted. This explained why only higher frequency light could cause emission, solving the mystery the wave theory couldn't.
Higher frequency light could cause emission, solving the mystery the wave theory couldn't. Okay.
Exactly. Classical wave theory assumed that making the light more intense, brighter, should eventually knock electrons out. But in reality, no electrons were emitted unless the light had a high enough frequency, no matter how intense the low frequency light was. Einstein's quantum explanation cracked this puzzle. The frequency of the photon sets the energy. Only photons with enough energy can free electrons. This was a foundational step toward quantum mechanics.
How did Einstein tackle this problem?
Einstein tackled it by flipping the perspective. Instead of assuming light was a continuous wave, he proposed it came in packets of energy. He applied Planck's constant, linking energy to frequency. Then he reasoned if each photon has a fixed energy, the electron only escapes if that energy surpasses the metal's binding energy. He wrote the famous equation, the energy of a photon equals Planck's constant times the frequency. This gave a threshold frequency. Below it, no electrons escape, no matter the intensity. It was a bold leap, explaining data others couldn't.
I think by proposing that wave is just a energy is just a quanta of particle, he I think he got the equation. That is the tricky part, and further he solved that. Okay, why it comes on the frequency was discrete because energy was quantized. So different frequency, different photons, different quantization means there are packets of waves are coming. Okay, there are a beam of light coming, but every light has different quanta of energy, and every quanta has its different frequency.
You've got the gist. Each photon is a little packet of energy, and that energy is directly tied to its frequency. So higher frequency light means higher energy photons. What Einstein saw was that each electron could only absorb one photon at a time. If that photon's energy was enough to break the electron free, it did. If not, no amount of more photons at low energy could help. Thus, different frequencies correspond to different photon energies, and the threshold frequency marks the minimum energy needed. That's the quantum leap.
Can you make conclusion what we have discussed?
In short, Einstein's 1905 photoelectric paper cracked a puzzle that classical wave theory couldn't. He proposed that light is made of discrete energy packets, photons, with energy proportional to frequency. When a photon hits an electron in a metal, it transfers its energy at once. If that energy surpasses the metal's threshold, the electron is ejected. Thus, the electron emission depends on frequency, not intensity, because energy is quantized. This was a cornerstone of early quantum theory and earned him a Nobel.
Okay, thank you.